everyone. We are Team 4 and today we present you with a language SeeMinusMinus. The name SeeMinusMinus derives from the fact that it does not consist of very rich features like that of the C language, but still it shares few similarities to it. Now starting up with the various features of SeeMinusMinus such as dynamic scoping and static typing. Also, it is a procedural based language. The tools that we have include Antler, Antler 4, that is the another tool for language recognition, and Eclipse. We are using Java for our runtime. Various features that SeeMinusMinus supports include basic arithmetic operation, functions, if-else condition, while loop, and also recursion and stack as a data structure. Now going through the reference manual, I would like to take you to demonstrate a simple snippet of the code. This is how we write the code in our language SeeMinusMinus, and this is how the intermediate code is shown. Similarly, this is how the parse tree is generated in SeeMinusMinus. Now further we will be going through other demos to get a clear understanding of the language.
So now I'll walk you through the sample codes for this language, SeeMinusMinus. So in Eclipse, we have created two projects, SeeMinusMinus and SeeMinusMinus runtime. SeeMinusMinus contains the grammar file, the listener file, and the compiler files. And SeeMinusMinus runtime contains the runtime for this language. So first I'll show you the grammar file, the grammar of our language. So this is the grammar which contains like print statement, while statement, if statement, function calls. So function call is the if contains else, that is optional, and in function the tower is the first. The tower is defined as tower identify equal to new tower, and the functions that are supported by the stacks are push, pop, and is empty. Int assignment is done by int identify equal to the integer or the int expression or the function call maybe. Similarly, the bool assignment, and this is the grammar file. So in the compiler, we'll set the path where our source code is saved. So for example, here this is where we'll change the path of the file .smm file, and in the listener there is a function called set file which will generate the intermediate file. So here we have to change the path for our intermediate code. So here this in sample programs intermediate.intr will be created, which will contain our sample the intermediate code for our sample program. In the runtime, this intermediate file will be taken as an input, which will then run the runtime, and then output will be generated. So here the path is set as per sample programs intermediate.intr. Now these are some sample programs. So first is the arithmetic if.smm. So here I have initialized two integers a and b, then c is provided the value of a plus b and d is provided a plus 20, then c and d are printed, and then there is also a visual example of a if else block. So if a is greater than b, then it will print a, else it will print b. So first in the compiler I'll set the path for this program, so arithmetic if.smm, and in the listener I can see that my intermediate file will be generated here. So first we'll run the compiler. So the compiler is run and the abstract syntax tree is generated, and as we can see the intermediate file is created at 9:29 p.m. and we can also see this intermediate file. So this is the intermediate code that is generated. Now this intermediate file will be taken as an input by the runtime. So if I'll run the runtime, it takes the intermediate file as input and then the result is shown. So if I'll show you, so a and b, then c is equal to a plus b, so print c will produce 60, and in print D will produce A plus 20 is equal to 30, and A smaller than B, so it will go in the else block and print B. So the result of B is 50. So this is the general arithmetic and if operations in our language. Now I'll show you another example in our language, which is a stack.smm file. So this is an implementation of stack in our language. So stacks are known as tower. So first we'll initialize the tower and then push, do some functions like push function, pop function, and check whether the stack is empty or not. So as we can see, the multiple stacks can be defined in our language. So if I'll change the path here, the name of the file is stack.smm. So I'll have to change it here, stack.smm. The intermediate file path will remain the same, and it will override the lastly created intermediate file. So if I'll save it and run it, so it has created an abstract syntax tree for this language, for this program with stack. And as we can see in our sample programs, this intermediate file is overridden at the same time. And if I'll open this, yeah, so this is the sample. So this is the intermediate code which contains stack start and some other operation related to stack. So now I'll run the runtime, which contains this, which takes as input this intermediate file. So this is the result that is generated. Okay. So tower, first we have initialized the tower ABC, then we have pushed a value 20, then we have pushed a value 50. Now if we'll pop from ABC, the result will be 50, and as the stack is not empty right now, so it shows false. Now if I'll declare another tower named DEF and then push value 20 in it and then pop the value from it, it will show result is 20, and now as this DEF stack is empty, so it will show that true. And after that, if we'll pop another value from ABC, the previous stack, it will show 20 as the 20 was pushed first, so the result is 20, and now the stack is empty. So this is the stack implementation in our language. The next example that we'll take is an example of factorial. In this factorial example, we can see the capability of our language to demonstrate functions as well as recursion in our language. So this is the syntax for our function. First we'll have to write the return type, that is int. It can be int or a boolean, then a keyword fn, which will denote that it is a function, then a factorial, then the identifier for the function, that is fact, and then optional parameters. So if I'll just change the path in our compiler, factorial.smm, and the intermediate code the path will remain the same. Now I'll run this file, and we can see the abstract syntax tree is created. Now as you can see, in the intermediate file is generated now. Now if I'll run the runtime, it takes this intermediate file, and the output is 120. So as we gave the factorial of 5, so factorial of 5 is 120, and this factorial is created using recursion. In the end, I will evaluate my project based on the requirements that were given to us. So the first, all the operators, for example, plus, minus, and multiply, and less than equal to, greater than equal to, are supported, and the primitive types, int and boolean, are supported. Our language also supports functions, which is strong enough to handle scoping also. For assignment statements, it supports the assignment of int and booleans. It also supports if-else construct, and for the iterative execution, we have implemented a while loop. For the data structure, we have implemented a stack, which is known as a tower in our language. Our function declaration is also strong enough to handle recursive calls, and the intermediate code that is generated is at the level of bytecode language, and it uses stack model machine model. So thank you.